Now changes within the nucleus in alpha, beta and gamma emission. So first emission is of alpha emission. See, alpha emission, we are having one equation. So is for example we are having Zxa. After emitting alpha, alpha emission means 2 helium 4 decays. So 2 helium 4, and that's why here atomic number is decreased by 2 and atomic mass is decreased by 4. So here we are getting one new nucleus, which is Y. So this is parent nucleus, and daughter nucleus atomic number decreased by 2 and atomic mass decreased by 4. So that is the simple reaction of alpha emission. It is also called alpha decays, right? So is for example, if we are having 92 uranium 238, so whenever it gives alpha particle, we get thorium decreased by 2, 90, and this is decreased by 4, so 234. So that is alpha emission. So 4 is lesser by this. So during this reaction, during this emission, we are getting some kind of energy which is in the form of heat energy, right? So that is alpha emission. Now second thing is beta emission. So beta emission, similarly I am writing first example equation. So here for beta emission we are having two types of emission. First is beta plus decay and second is beta minus decay. For beta plus, if we are having beta plus, so plus 1 E0 will be emitted during this reaction, and this is known as positron. So positron is produced during this reaction, so we are left with Z minus 1 Y A as it is. So here no changes occurs in atomic mass, but only change that atomic number decreased by 1. So this is called beta plus decay. Now second equation of beta minus decay. So Zxa, it gives here, now electron is emitted during this reaction. So now we have Z plus 1 Ya. So during this process beta minus decay, in this process we are having atomic number which is more now by 1, right? So see, this process actually electrons is outside the nucleus. So how this process occurs? Actually this process behind we have one another process. So is for example we have neutron inside nucleus. So neutron means 0 and 1 only. So how this reaction occurs? See here what we get, minus 1 E0 electron emit. So because of with this electron we are getting one proton. See, 1 minus 1 0, 1 plus 0 is 1. So this is beta minus decay. So this reaction is nothing but this reaction. So behind this reaction actually this occurs, and for this beta plus decay, see we are having for beta plus decay 1 proton 1, it gives here 0 neutron 1 plus positron. So behind this equation we are having actually this equation. So both particles neutron and proton are inside nucleus. So these reactions are also done in nucleus itself. So is for example we are having one example 6C12, and during this emission one electron emitted. So what we are getting, nitrogen 7 and 12. So this is of beta minus decay, but behind this reaction we are having this reaction, first one, right? And now another formula which is Na. So 11 Na 23, it gives here positron will be emitted. So see, 11 Na sodium. Now I have to write 10. It is neon 23. So this is of positron, beta plus decay. So behind this equation, actually behind this reaction, we are having this reaction, proton emission. So this is how beta emission takes place. In beta we are having beta plus and beta minus, and the third one is gamma emission. So gamma emission, if we have ZXA, it gives similar, no other emission, so that's why it is remains constant. This is parent nucleus, this is daughter nucleus, and we are having some energy here. So gamma will be emitted during this process. So how this process actually occur, why this process occur? Whenever this element is in unstable state, then that element want to get stable state, that's why it emits gamma rays, and now it is now in stable state. So gamma emission is only convert unstable state element to stable state element, so that is why gamma emission occurs. So here these are some changes within the nucleus in alpha, beta, gamma emission.